So remember this thing. So just take the screenshot. I think we have not taken the screenshot. Have you taken the screenshot in the last class?
Yeah.
Okay, so
Yes, sir.
today we will drive this. Means how this is coming. We will drive this. So for the derivation of this, so any two medium you can take. This is a object, and this is suppose any medium. Here is the water. Water is there. Okay. So the water is, if the water is there, and this object, and here is the air. Here is the air. Here is the air. Water. I am not saying this can be only water. It can be any other medium also. Air. And the exact location or exact position of this is this. From the surface we will measure. Okay. So this is at a distance of d, and this d is known as the real depth. Real depth. Okay. So now what will happen? From this object, first ray of light, I am just striking like this. It is going normal. It is the normal incidence. So the light will move straight. We have discussed. Another ray of light from this will be like this. Suppose going like this. And if this is like this, then this time the light is moving from denser to rarer. Suppose this is the normal. So when the light is moving from denser to rarer, what happens? Moving denser to rarer bends away from the normal like this. And when you will produce this ray in the backward direction, then somewhere here you will get the image where the two rays will appear to meet. Means finally the ray will appear. Finally the object will appear here. Okay. So this will be the apparent position. This is the object again, and this object is at a distance of d dash, and d dash is the apparent depth. D dash is the apparent depth. Okay. So this is suppose d dash, and we are measuring all the distances from the surface or from the interface, you can say. Now we are studying the geometrical optics. So geometry will be used to solve the problems. This is the normal, and one, suppose this is n and this is n dash. For example, suppose this angle is angle of incidence I. So this light is coming from this object like this. This angle is I, and this angle is R, angle of refraction. One thing is very clear: this and this parallel, and this is the same line. So this angle will be also R. Geometry. Okay, this angle will also be R. Remember this thing. If you have Nafisa and Nawal and Matthew, is my voice okay? Everything
Yes.
okay?
Yes, sir, it's okay.
Okay, fine. So if this is the case now, and if it is given that if this is a straight line, and if one line is this and another line is this, for example, 9th class geometry. This is. So if someone is saying this angle is theta, then in that case this angle will also be theta. This is the same line and these are two. This is the concept that I have used here. For example, this distance I am supposing x. Okay, this distance I am supposing x, and this is suppose O. And this is the image we are getting. O means object, I means image. Now give this as name A and B. This point is A, suppose, and this point is B, suppose. You can give any other name depending upon you. So now first the refraction is taking here also here there is no refraction taking place because there is the normal incidence. Here the refraction is taking place. Now we will apply the Snell's law. Snell's law, apply Snell's law. At B, we are applying Snell's law. What is Snell's law? Refractive index. Refractive index of water is N2 and refractive index of air we have assumed N1. So Snell's law, when you will apply refractive index of medium 1 multiplied by sine of angle with normal. So okay, first choose a medium. We have chosen the medium. This medium we have choose. Okay, so in this medium, what is the refractive index? N2. So you will write N2 and you will multiply it with sine of angle with normal. So what is the sine of angle with normal? Sine I is equal to, what is the medium here? What is the refractive index? Is another medium N1. N1 multiplied by sine of angle with normal. What is the sine of angle with normal? Is another medium R. R. Okay. But what happens now? These angles means I and R are very small. Why these are very small? Because these rays, this ray and this ray, are almost parallel. Paraxial rays are there. This is the assumption. Okay, this is the assumption that rays are paraxial. Paraxial. So I and R are very small. Okay, so rays are paraxial. So paraxial means these rays are parallel, these rays. So you can see if these rays will be parallel, so angle I and angle R will become very, very small. If angle I and angle R is very, very small, then you can write sine I approximately equal to I, and this I can be written as approximately equal to tan of I. Similarly, you can say sine of R can be written as approximately equal to R, and this can be written as approximately tan of R. Earlier also we have done these things. So now you can see this equation. Instead of sine I, you can write tan I. So you can write N2 into tan I is equal to N1 into tan R. Now see in this triangle. One more thing I want to tell you. This line and this line parallel. Okay, this line and this line parallel, and this line is same. So this angle will also be I angle. This angle will also be angle of incidence. Okay, this angle is equal to this angle from the geometry. Okay. Now see triangle OAB. See triangle OAB. In triangle OAB, in triangle OAB, see what is tan I. We want to calculate tan I. So tan I is x. Okay, tan I will be x divided by OA means D. Okay, tan I will be this AB divided by OA, perpendicular divided by base of this triangle. So AB divided by OA, you can write AB divided by OA. AB divided by OA. So AB we have assumed x and OA is D. So tan I is this. You can find tan R also. So tan R you will get from triangle IAB. So in triangle IAB, tan R, what will be the tan R in this triangle? So again, this is x divided by this distance. X divided by this distance. What is this distance? This distance is d dash. So x divided by d dash, perpendicular divided by base. And this AI and this d dash are the same distance, na? So x divided by d dash you can write. X divided by d dash. Now put the value of tan I and tan R in this equation. So you will have N2 tan I is x divided small x divided by d, and N1 you will have N1 multiplied by tan R, you will have x divided by d dash, x divided by d dash, and this x and x will be cancelled out. So you will have N2 by N1, N2 by N1 is equal to d by d dash. And what is d by d dash? D is the real depth and d dash is the apparent depth. Apparent depth. Okay. So in this way you can prove that. Okay, take the screenshots. Done?
Yeah.
Yes, sir.
Okay.
Yes, sir. Done.
Okay.
Yes,
So
sir.
now we will, okay, fine. Now we will solve one question on this. Remember N2 by N1 is equal to real depth divided by the apparent depth, and N2 is the refractive index of the medium from where the light is coming. N1 is the refractive index of the medium to which the light is going. This question. So now this is the air here, a bird is flying. This is a bird. This is a bird, okay? This is a bird and this bird is flying in the sky, and there is a fish in the water. Fish will be in water. And this is the interface between the air and water. And the fish is at a distance of 24 centimeter from this interface. Means this is the real position of the fish, real depth of the fish. And this bird is at a distance of 36 centimeter from the interface. This is the interface. And water refractive index is given, air refractive index is given. We have to find the depth of the fish seen by the bird. This bird will see this fish. This bird will see this fish due to the refraction. The actual position of this fish will be shifted. Okay. Like here you can see. In this case also when you will see from the outside the position of something which is underwater, so it will be shifted upward na for you, but actually the object is here. So for the bird also the same thing will happen. This fish will be somewhere here, so that we want to find that the apparent position. Simple. Apply the formula N2 by N1. Now first see here what who is the observer and to whom observer is observing. This thing should be clear. Who is the observer here? Observer is bird this time. Observer is bird. Okay. So light will come from fish to bird. Light will come from fish to bird. Means light will come from water to air. Light is going from water to air. So you will say light going from water to air. Water to air. So if light is going from water to air, means N2 you will take, in this case N2 you will take the refractive index of water, and N1 you will take refractive index of air. Earlier also I have told you, N2 we will take the refractive index of the medium from where the light is going, and N1 we will take the refractive index of the medium in which the light is going. Now apply the formula N2 by N1. Otherwise this will become very confusing to you. This apparent depth and real depth. N2 by N1, apply just formula. N2 by N1 is equal to real depth divided by apparent depth. Real depth, that is D, divided by the apparent depth, D dash. Real depth, D is the real depth and D dash is the apparent depth. Okay, D is the real depth of fish. D dash will be the apparent depth of fish. Okay, what is N2 here? N2 is the refractive index of water, that is 4 by 3. N1 is the refractive index of the air, that is 1. So N2, put the value of N2 4 by 3 and N1 is 1. What is D? D is the actual depth, that is 24 centimeter. We will measure the distance, we will take the distance from the interface, 24 centimeter. So right here 24. And D dash you want to find. What is D dash? D dash is the apparent depth. Now you can find out. So d dash will be 18 centimeter from the surface. So this fish will be appear to this bird somewhere here. Fish. And this fish will be at a distance of 18 centimeter. Apparent position. Okay, this will be the image, you can say, of the fish. This will be the d dash. This will be d dash. So now, can you tell me depth of the fish seen by the bird? What will be the depth of the fish seen by the bird? Can anyone tell me? This fish will appear to this bird here.
18 centimeters.
No. 18 centimeter is the fish is appearing from the surface, but from the point of view of the bird, this will be
Oh, 24.
36 plus 18. 36, because
Oh, yeah,
actually
at the top as well. Yeah,
huh,
yeah.
actually the bird is here. Actually the bird is here. So they are saying depth of the fish seen by the bird. So this will be the one, no, means this will be the depth. No, this is the bird. This will be the depth between. Depth means you can say the distance between the bird and the, but we cannot say that. Okay, so we have to add this 36 plus 18. So depth of fish seen by bird. So you can write depth of fish seen by bird is equal to 36 plus 18. 36 plus 18. This fish will appear here. 36 plus 18. It will be 54 centimeter. 54 centimeter. So this fish will be appear to be at a distance of 54 centimeter. 54 centimeter. Okay, very good. Now, second part. Second part just opposite to it. This question is not very interesting. It's okay. Now this is the condition given. Here all things are just same. Now they are asking what is the depth, what is the height of the bird seen by the fish? What is the height of the bird seen by the fish? 24 plus 36. Fish is here and bird is here. So the height will be 24 plus 36. No. Because due to the refraction, the position of the bird with respect to fish will change due to the refraction of light. Like you can see the bending of the pencil when dipped in water. So due to the refraction, the real and the real position appear to be somewhere else. Means the position appears to be somewhere else. Okay. So now in the second answer. Answer number second. They are asking find the height of the bird seen by the fish. Now who is the observer? This time the observer is fish. The observer is fish means the fish is watching this bird. So light will come from this time You will consider light is coming from air to water. Coming from air to water. Why the light is, why you are considering light is coming from air to water? Because this time our observer is observing something. Means I am just watching this bulb. I am the observer now. So light is coming from the bulb now. Light is coming from the bulb. Hmm? So in this case also the fish is watching the bird. So light is coming from air to the fish, air to the fish. That is why this fish is able to see this bird. And by the refraction, this bird appear to be somewhere else. Now what will be N2 here? N2 is the refractive index of the medium from where the light is coming. So this time the light is coming from air. So N2 is 1. And what is N1? N1 is equal to 4 by 3. Now very easily you can apply N2 by N1 is equal to real depth divided by the apparent depth. So N2 is 1 and this is 4 by 3 is equal to D apparent depth. Now apparent depth of bird you will take 36. Real depth of the bird you will take. This is the real depth of the real height of the bird, and height we will take from the interface 36 and D dash we want to find. So it will become 3 by 4, 36 by D dash. So it will be cancel out. So what will be D dash? D dash will be 48 centimeter. So from the surface, the bird will appear at a distance of 48 centimeter. This bird will appear at a distance of 48 centimeter, means somewhere here. This is the actual position and this will be the apparent position of the bird. Apparent position. And this apparent position is at a distance of 48 centimeter from the surface. I have told you we will take the distance from the surface for calculating this formula, by calculating this formula. Now can you tell me what is the height seen by the fish? What is the height seen by the fish to the bird? According to the fish, what is the height of the bird? Can anyone tell me?
Height of the what, sir?
I am saying that this is the apparent position of the bird,
Yes, sir.
and this is the fish. Okay. So now I am saying with respect to fish. Now what is the height of the bird?
48 plus 24.
Yeah, 48 plus 24. Why? Because this bird will appear here, not here. This is the object here. Here the image will form. So you will see image, not. So it will be 48 plus 24. So height of bird seen by fish is equal to 24 plus 48. That is 72. 24 plus 48. 72 na? 842. 72 centimeter. Okay. Okay. Take the screenshot fast. This is your answer number 1. Okay. Remember. Answer number 1. Done.
Yes.
Completed, Nafisa and Nawal?
Yes, yes, sir.
Just wait. Okay, now take the screenshot.
Done.
Okay.
Yes, written.
Okay, so now we will see the refraction of light through glass slab. Okay, glass slab is there in lab. You
Yeah,
have
sir.
seen that in lab there is a glass slab. We have
Prism, you mean, sir? Glass slab or glass prism?
No, glass slab, glass prism. We will
Glass
study
slab.
later.
Yeah, yeah. Okay.
Both
Yeah, we see.
things are available in when I was in 12th. In my lab there was glass slab also and prism also. And when I was in engineering, then also we have done some experiment in physics. Okay, by the way, shift through the glass slab. So this is a glass slab. This is the glass slab. Actually, glass slab is basically like this. Glass slab is made up of glass, we know. But suppose this is made up of glass, this thing. Okay, this is something and this something is made up of glass. So glass slab is like this, but you can consider the color of this is white and this is made up of glass. What happens na, refraction of light takes place. What happens when you will suppose here is some text, here is my copy and anything, and when you will see through the glass slab, so there
It will
will
be
be
in a different
shift.
place.
Yeah, there will be some shift in the text or in the object if you will place. So, and this is happening due to the reflection of light. And now we will see how this is happening. How this is happening. But at the same time, you should know from where you are just watching. Actually, you will watch like this. Means from this will be the thickness. This sorry, this is the thickness. Okay, so this portion like this, and in an expanded way, this portion you will see from here, and object will be here. Your eyes are here, and the object is here. So I have just zoomed in, and I have made this picture here. So here is your object. This is your object. Here is your object place, and you are watching from this side. Your eyes are here, and eyes are there. Okay, so eyes watch in us means eyes has the ability to see in a straight line always. We always see in a straight line, not like this, like this, like this. We always see in a straight line. and this is the object here. Okay, so if this is an object and we know the object is a source of light, so from this object the light ray will be like this. This is the glass medium, na? This is a glass slab. So from this object a light ray is suppose like this. For example, suppose now this is the incident ray, and this here is the air. Here is air also, and here is air also, because around us there is air, and this is a glass slab. So there is one light ray like this, and this light ray is moving from air to glass, means changing the medium. Bending of light will take place. So how the bending of light will take place? For that we will draw normal. So normal to the surface will be like this. Normal to the surface will be like this, and as the light is going from rarer to denser medium, as the light is going from rarer to denser medium, air is the rarer and glass is the denser medium, it will bend towards the normal. Fine, it will bend towards the normal. Okay, it will bend towards the normal. So due to that, when you will just produced this ray in this direction, means like this, just a minute. When you will produce this refracted ray, so you will get the image like this. Bending towards the normal, na? So it will be bent towards the normal, suppose like this. Okay, and when you will produce this ray in the backward direction, so it will appear somewhere here. Okay, it will appear somewhere here, this ray, and this will be the image, and this image, this is the image. When there is an observer which is watching the light ray from this slab. Okay, if you are watching this object from the glass slab, then it will appear here. It will appear here. Now finally what here, finally what is happening? Finally the light ray is just bending towards the normal. Finally the light ray is bending towards the normal, and it will leave the glass slab, and here the refraction will take place as this ray is leaving from glass to and moving to air. So refraction will take place. Refraction taking place means there should be a normal here. We will draw the normal like this. Okay, and we know that light this time is traveling from denser to rarer, from glass to air, so it will bend away from the normal. It will bend away from the normal. Away from the normal means like this it will travel. It will be like this. It will bend like bend away from the normal. Okay, bend away from the normal, and when you will produce this ray in the backward direction, so it will appear that this is coming from here. Okay, it will appear that it is coming from here. So we have to draw like this. Actually, on pen and paper, it is easy to draw if you have a scale. So finally, the image is here. Finally, the image IF means final image of this object is here. Okay, this is the final image of the object, and this is known as the shift. This distance is known as the shift. This distance, the distance between the object and the final image, is known as the S. S means shift. So S is the shift. The object is here, but it will appear to you here. This is known as the shift. And O is the object. And again, I is the image. I is the we should write IF. We should write IF. IF means the final image. And the thickness of the slab is T, suppose. Thickness means this portion. Means thickness means this length, okay? This distance. So to calculate this shift, again we have to apply the Snell's law. Again, real depth and apparent depth we will just do, and finally we will get the answer of the shift. Shift is given by S is equal to thickness of the slab 1 minus 1 upon refractive index of the glass slab. So remember only this formula. Numerical can be solved easily. And mu is the refractive index of glass. Mu is the refractive index of medium, you can say. T is the thickness of the slab. T is the thickness of the slab. T is the thickness of slab, glass slab. So finally, where the image you are getting, here you are getting the image. This is normal and this is also the normal. This is the first surface, means from this surface the refraction is taking place, from this surface also the refraction is taking place. We will apply Snell's law here, and again, then here we will get this result. So okay, so okay, please take the screenshot. Taken?
Yes.
Yes.
Okay, okay. This formula will be used when we will solve the numericals. Now there are few points that I want to write here. Some important points regarding this glass slab. Points. Number one, here na we are considering rays are paraxial, and another point is that if medium on both sides of glass slab is same. It can be air also, it can be any other medium also, but it should be same, but not air. Then in that case, the shift will given by T1 minus refractive index of the surrounding medium divided by the refractive index of the slab. If not air on both sides, if any other medium is there. Okay, so write down this. This is the only important point. Other points are now we will solve questions on this formula and this formula. This is valid when both side air. This is valid when both side is same medium. It can be air also, it can be any other medium also. Then Matthew, completed?
Yes, sir. Yeah.
Okay, okay. Now we'll solve question. First question is this. Very easy question. Simply you have to apply the formula. They are saying that in this question, they are saying that this is a glass slab. This is the glass slab, and both side of the glass slab is air, and this is the object placed. O is the object, and thickness of this slab is 15 centimeter. Okay, thickness of this slab is 15 centimeter, and they are asking the shift. Okay, they are asking the shift, find shift. So for shift we have the formula. S is the shift, is equal to thickness of the slab 1 minus 1 upon mu. Why I am applying this formula? Because both side air. Put the value. Thickness is 15 centimeter. 1 minus 1 upon refractive index of the glass slab. Refractive index of the glass slab is 1.5. So we can solve it. It will be 15, and here 1.5 minus 1 will be 0.5, and here is 1.5. So when you will cancel this out, it will be 10. So it will become 5 centimeter. 5 centimeter shift will be there. So 5 centimeter shift means initially the object is here, but finally the object will appear here. The image of this object will be here. So this will be the shift of 5 centimeter. 5 centimeter. Okay? Another question, same question, but something is changed here. Glass slab is there, and object is placed at a distance of 10 centimeter, and but this time both side on the glass slab the medium is different and having a refractive index 2. Okay, medium is different and refractive index is 2. So in case if the if on both side of the glass slab the medium is different, so what was the formula I have told, means we have written this formula. So now we will use this formula. Shift will be thickness of the slab, that is 15, 1 minus refractive index of the surrounding medium. What is the refractive index of the surrounding medium? 2. Surrounding medium is 2 and refractive index of the glass slab is 1.5. So here you will get 15 and 1.5 minus 2 and here is 1.5. So it will be 10 and this will be 1.5 minus 2 minus 1.5 means you will get minus 5. Shift, you are getting negative shift. You are getting negative shift. So there are two note points that should be noted. Okay. So complete this T1 minus refractive index of surrounding divided by refractive index of slab. Distance of the object from the slab does not matter for the shift. This point, if shift is positive, shift is in the direction of the incident ray. If shift is negative, then it is in the opposite direction of the incident ray. So this concept will be used here. Now here na shift we find it out plus 5 centimeter. So this will be in the direction of the incident ray. So incident ray will be in this direction. Object will give the light in this direction. So shift will be in this direction. But here shift is negative minus 5 centimeter. So it will be in the opposite direction of the incident ray. Means the object will appear here. Finally, the object will appear somewhere here. And this will be the shift this time, 5 centimeter shift. In the opposite direction of incident ray. So incident ray will be in this direction, but the shift will be in this direction. Okay, write down. Done?
Yes, sir.
Okay.
Yes, sir.
After completing this, we will discuss what is the critical angle and what is the total internal reflection. Total internal reflection. So before that, I think you also note down these points. These points. These are some important points. Please take the screenshot of this point.
Yes, sir. Done.
Okay. Now we will discuss what is the critical angle and what is the total internal reflection. Total internal reflection. Okay. critical angle. Critical angle and total internal reflection. Okay. So hmm. Okay. So this is some surface. Okay, this is some surface, and these are the normal I have drawn. So why I have drawn all these things? So you will get to know now. Suppose first the incident, and this is the hair, the denser medium. And here is the rarer medium. The light is traveling from denser to rarer medium, for example, suppose. So angle of incidence is this. As the light is traveling from rarer to denser medium, it will bend. It will bend away from the normal. It will bend away from the normal like this. Okay. This is angle I1 suppose, and this is angle R1 suppose. Now again I have increased the angle of incidence. I have just increased the angle of incidence. First I have just incident the light ray at this angle. After that the angle of incidence I have just increased little bit. So accordingly the angle of refraction will also increase. Light ray will go like this. This is I2 and this is R2. Now I have increased the angle of incidence to such a angle such that this is the angle of incidence this time. This is the angle of incidence such that the light ray will suffer, like go along the surface. This is the angle of refraction and that is equal to 90 degree. So light is going from rarer to denser, as we are increasing the angle of incidence, the angle of refraction is increasing, here increasing. Now you have just increased the angle of incidence as much. For that, the angle of refraction becomes 90 degree, so that the ray is grazing through the surface. This is the refracted ray, and that angle of incidence is known as the critical angle. So basically, this I is equal to C. This is known as the critical angle, the angle of incidence for which the angle of refraction becomes 90 degree, and there is a grazing of refracted ray C, and this is known as the critical angle. Critical angle. So what is happening here? Grazing emergence. Okay. Now, if suppose you have incident a light ray with an angle of incidence greater than the critical angle, then what will happen? For example, if the angle of incidence becomes greater than the critical angle, then see what will happen. If suppose this is the angle of incidence I, and this I this time is greater than the critical angle, but the condition is that the light ray is moving from denser to rarer medium. So in this case now, there will be no refraction and there will be reflection, and that will the total internal reflection. This angle will be R, and we know that angle of incidence is equal to angle of reflection, as here is the reflection taking place. Here is the reflection taking place and without the mirror taking place. Almost 100% you can say light is reflected here. You can see the light is moving from one medium, trying to moving from one medium to another, means denser to rarer. But when the angle of incidence becomes greater than the critical angle, then total internal reflection will take place. So the examiner can ask you what are the conditions for the total internal reflection. Conditions for TIR. TIR means total internal reflection. So you can write, first condition is the light is moving from denser to rarer medium. First condition is light should move from denser to rarer medium. Denser to rarer. Second condition, the angle of incidence must be greater than the critical angle. And you should know what is critical angle. The angle of incidence for which the angle of refraction becomes 90 degree. And there is a grazing of light. Now we can calculate this angle of, we can calculate the critical angle. Calculation of critical angle. So light is moving from denser medium to rarer medium, and such that the angle of incidence is such that for which the angle of refraction becomes 90 degree. So this is the reflected ray, and this angle is 90 degree. Suppose the refractive index of this denser medium is mu2, and suppose the refractive index of this rarer medium is mu1. Now we will apply Snell's law. We will apply Snell's law to find the angle of means the critical angle. So here, what is I? In this case, the angle of incidence is equal to the critical angle. So we can apply the Snell's law. Snell's law. How to apply the Snell's law? Refractive index into sine of angle with normal. This is normal. Remember, this is normal. This is interface. Okay. This is normal and one. This is normal. Another normal. This is another normal. So apply Snell's law. It will be mu2 multiplied by sine I is equal to mu1. Now what is the angle with normal this time for the reflected ray? Refracted ray, this is the refracted ray. This time the refracted ray is moving along the surface, so angle of refraction is 90 degree. So now it is mu2 into sine I, mu2 into sine I. Sine, what is I? I is C. It is mu1. Sine 90 is 1. So you can find the critical angle mu1 by mu2. This will be the formula. What is mu1? Mu1 is the refractive index of rarer medium and mu2 is the refractive index of denser medium. Mu1 refractive index of rarer medium. What is mu2? Refractive index of denser medium. If the rarer medium is air, for example, mu1 is equal to 1. If rarer medium is air, means mu1 is equal to 1. Then from this equation you can write sin c is equal to 1 upon mu 2 and mu 2 is equal to mu. Okay, means the refractive index of another medium is given as mu. So you can write sin c is equal to 1 upon refractive index, and most of the time you will see this. Now one question on this. Question is find critical angle for air refractive index is equal to 1 and glass refractive index is equal to 1.5 interface. Very easily you can find the critical angle. Sine of critical angle is equal to refractive index of rarer medium divided by refractive index of denser medium. Refractive index of rarer medium divided by refractive index of denser. So sine of C is equal to refractive index of rarer. What is rarer here? Air is the rarer medium, glass is the denser medium. 1 upon 1.5. 1 upon 1.5, it will become 2 by 3, I think. 2 by 3. So critical angle will be sine inverse of 2 by 3 and this will be approximately equal to 42 degree. So the critical angle for the air glass interface is 42 degree approximately. You can write the answer like this also, sine inverse of 2 by 3. Then also your answer will be same, means considered. Nawal understood what is total internal reflection
Yes,
and what is critical angle, and Nafisa and Matthew.
Yes, sir.
yes, sir.
Then you will again and again increase the angle of incidence, but the condition is that the light is traveling from denser to rarer, and there will be a particular angle at which the angle of refraction becomes 90 degree, means the light will move along the surface, and if the angle is greater than that critical angle, then total internal reflection will take place. Okay, write down. Take the screenshot.
Yes, sir.
Done. And this topic is important. Okay, so don't confuse, means clearly understood it clearly. Done.
Yes, sir.
Okay, so now just means calculating a critical angle is not a big deal. Just you will apply the Snell's law, but the condition is you should know how to apply the Snell's law. Again and again, I have told you how to apply the Snell's law. Taken? All of you?
Yes, sir.
Yes, sir.
Okay.
Yes, sir. Taken.
Okay.
Done.
You are taking screenshots. It's very good. Okay, it is saving the time. But remember one thing: these screenshots should be in a proper order. Otherwise, there will be no use. Hmm.
Yes, sir.
These screenshots should be in the order. If you will give me also, these are the my notes, you can say. I'm just writing me also. If you will give the random pictures or random screenshots, even I will not able to understand what I have written. So how you will? So okay, so we are studying the geometrical optics. Okay, so geometry will be used again. Last question of this class. Very interesting question. And this question, try to solve by yourself. Actually, hmm. This is a surface of glass. What surface? A surface of glass. And this surface is of glass, and this surface made up of glass and having the critical angle 42 degree. And here is air, and a ray of light is just going like this. This is the incident ray. Okay, incident ray na? You have to find the, or if you can say, complete the path of ray. Can anyone try to solve this? Here is air, or this glass, this means piece of glass in the form of the quarter of a sphere is around it air. Okay, around it is air, no problem. Just try to complete the path. I am giving you 3 minutes. Apply your all the minds and all the, except the Google Lens. Okay, now see, this is the incident ray, and this is the glass, and critical angle is given. Oh, sorry, one thing I have not given here. Without in this was, I have given the
Refract.
income. No. This angle is 42 degree. Okay, now I am solving. Okay, because I have given the wrong question. This angle is 42 degree. Okay, so this angle is 42 degree, this angle. So this is the incident ray. So here is the light is just trying to move from, means here this is the path of the light. So as it is looking, light is going from this glass to the air, means denser to rarer medium, so what we will do, we will draw the normal. So this is the normal, suppose, and if this is a normal, so if this is the normal, so this whole angle is 90 degree. This whole angle is 90 degree. So the angle of incidence will be 48 degree. This angle will be
Yes.
48 degree. This is the angle of incidence. This is 48 degree. So you can say the angle of incidence is equal to 48 degree. But here, see, the critical angle is 42 degree. Here the angle of incidence is greater than the critical angle. So if the angle of incidence greater than the critical angle, total internal reflection takes place. Now of this ray, the total internal reflection will take place. Total internal reflection will take place like this. So if this angle is 48, this angle will also equal to 48 because angle of incidence equal to angle of reflection. So this is also 48 and this angle is 90 degrees. Remember this thing, as this is the normal. So this whole angle will be 90 degrees. So you can say that this angle will be 42 degree again. If this angle is 42 degree and here light is coming incident at this point, if this is the normal, then see this line and this line are parallel. This is 42, then this is also 42 degree. Geometrical optics, okay? So geometry is using. So if the angle of incidence this time, here the angle of incidence greater than the critical angle, but here the angle of incidence equal to the critical angle. What happened in case when the angle of incidence becomes equal to the critical angle? Grazing will take place. So light ray will move like this. I'm just making it green color, with white color. Okay, no problem. So light will travel like this. Like this, the light will travel. Finally, this will be the path of the light. Why? Because angle of
Because is
incidence
equal to
becomes,
the critical angle.
this angle will be 90 degree. Angle of R. Okay, so take the screenshot.